Thanks for joining us today for a good discussion about Army modernization and how we can work together to develop the capabilities that are for our Army to be successful on the future battlefield. We're honored to be the first act on the government stage for GEOINT 22. Our modernization efforts are necessary to ensure that we achieve overmatch against strategic competitors who continue to enhance their capabilities for challenging our Army, our joint force, and our allies. And by doing so, they challenge the international order and our way of life. So it's no small task for us to modernize our force. Modernizing the Army is a complex effort that spans the major components and commands of the Army and is undertaken in coordination with our joint partners and our coalition partners. So that's the second time I've mentioned our allies and partners. And General Clark gave a great treatise on how important our partners are. And we welcome all of them to the symposium and to our modernization enterprise. And as Director Cardillo, former Director Cardillo noted this morning, today is ANZAC Day. So especially important for our Australian and New Zealand partners with us today. We approach modernization in a holistic way, starting with the threat we will face to inform our work to deliver warfighting concepts, requirements, design the future force, and support modernization solutions. Army Futures Command was created in 2018 to synchronize and integrate the many partners who have critical roles in modernization. So we carefully selected the panel for the GEOINT 22 symposium to address your interests in how the Army will leverage GEOINT in the future operational environment. Specifically, Colonel Jimmy Blejski is with us from Headquarters Department of the Army, G8, where he manages the entire investment portfolio for all Army intelligence, electronic warfare, and sensors for the Army. Brigadier General Steph Ahern is the Director of Concepts in the Futures and Concepts Center, stationed in Austin at AFC headquarters. Steph is responsible for developing the operating concept by which the Army will fight in the future. The basic premise is that in the future operational environment that is shaped by a multitude of variables, not the least of which is technology, the Army will clearly fight differently than we do presently. Mr. Mark Kitz is the Program Executive Officer for Intelligence, Electronic Warfare, and Sensors, PEO-IEWS. The PEOs are part of the Assistant Secretary of the Army for Acquisition, Logistics, and Technology, ASALT. A key program in Mark's portfolio is the Tactical Intelligence Targeting Access Node, better known as Titan. Essentially the next generation ground station that will downlink all forms of data that is collected from air and space to include GEOINT to make it available to combat operations formations. Many of you know the next panelist that I'll introduce, Mr. Willie Nelson, who has served as the director of the Assured Positioning, Navigation, and Timing and Space cross-functional team. He did that for a number of years. Recently, within the last 2 weeks, as a matter of fact, Willie has fleeted up to be the new Deputy Assistant Secretary of the Army for Research and Technology, also part of ASALT. It's great to have Willie here today in his new role to help reinforce that Army modernization really is a team effort. We are fortunate to have with us today Mr. Mike Monteleone, sitting here in the front row, who is Willie's successor at the AP&T CFT. So great to have you joining us today, Mike. And finally, we have the director of one of our cross-functional teams assigned to Army Futures Command, Major General John Rafferty. John is the director of the Long Range Precision Fires CFT. So all the work that we are doing on sensor to shooters, you've got essentially the team here that play key roles in that, sensors and shooters. LRPF is the Army's first modernization priority, and John is responsible for leading the effort to determine requirements for future indirect fire systems and bring prototypes into existence. So as you can see, the members of the panel represent many parts of the modernization enterprise and all have a particular interest in reaching the advantage that we derive from geospatial intelligence. We recognize that the richest part of this discussion will be questions and answers from you. So each of the panelists is going to give a very brief statement about what their role is beyond what I just did, and then we'll go straight to questions and answers from there. Jimmy, why don't we start with you?
Okay, sir, thanks. So Army modernization has a lot of stakeholders, but I would say the unofficial tri-chairs of Army modernization are represented by the three organizations that are up here today, ASALT, AFC, and the G8. And my role in the G8 is to provide the funding and the programming, the planning, the programming, and the budget for a lot of the things that the other panelists execute. In the IAW portfolio, we describe it in 4 layers, the space layer, the aerial layer, and the terrestrial layer. And those mostly consist of sensors in those layers. And underneath those 3 is what we describe as the foundation layer. It's actually pretty coincidence that this year's theme, the foundation of intelligence, we have a foundation layer, and in that is everything from analytics to processing, evaluation, dissemination, and with that, there isn't a capability in that foundation layer that isn't reliant on GEOINT or geo-rectified data. So I really look forward to your questions.
General Ahern.
Thanks, sir. So from a concepts perspective in the Army, a concept is an aspirational way of how you could operate in the future. Either the technology doesn't exist, you're using technology in a different way. Think World War II, the Germans used technologies that exist in World War I in a very German way to have tactical and operational effects, or both. You're using new technologies in new ways to operate differently. So we must develop concepts with many different partners. It's absolutely essential that as we're thinking about new hypotheses, we also must experiment with it first, which makes it's not flashy, it's not fast. We also don't take a lot of money to experiment up front. And so you may not hear as much about concepts. However, these are important but not urgent topics because we know future warfare is going to be differently. And we have to start planning now for how things will be different. Our concept right now is the multi-domain operations, and so that's taking into account the layered threats to even get to where we need to go. We, of course, are having the air, land, sea, but the space and cyber. Information warfare is going to be a part of what we're doing today and in the future, and we have to be prepared in competition, crisis, but then into conflict. So those aren't changing. However, what we are looking at right now from a concepts perspective, as the concept is getting put into doctrine, as we are changing our training, we're changing our education, we're looking at when you have AI, autonomy, robotics, synthetic bio, quantum computing, advanced manufacturing, additive manufacturing at scale for us, and those who may want to choose to go in a different direction. And so those are the challenges that we're facing right now. We're working across those from the informed from the threats, informed from our S&T community, and why we also appreciate being here to understand from a leading edge perspective from our partners, industry, where we're going. Thanks.
Mark.
Good afternoon, everyone. Firstly, I want to say thank you very much for having me. I see a lot of familiar faces, both industry and government. And this collaboration is absolutely key to Army modernization. And so thank you for being here, and thank you for having me. I am the PEO for Intelligence, Electronic Warfare, and Sensors. Somewhat a broad portfolio, but very relevant to the geospatial community and the intelligence community. So we equip every intelligence analyst, every intelligence professional in the Army gets a capability from our PEO. And what underpins all of that is the data that we provide them, right, across the intelligence community. And so to this community specifically, you already mentioned the Titan program, and I'm sure there'll be questions on the Titan program, but really Titan program is really setting the foundation for how we deliver data, how we deliver capability to those analysts. And doing that in a joint environment so that we can do it in an agnostic sensor way. So our first foray into this Titan capability is building out a foundation so we can deliver the data that's needed to our sensors, to our shooters and to our intelligence professionals. And so you're gonna hear from my counterparts at the cross-functional teams that are gonna talk about how that leads to operational outcomes and working in this collaborative and iterative way so that we can deliver our warfighters what they need. That's on the Titan piece, but we also have significant investments in our tactical geospatial collection and our tactical geospatial intelligence professionals. All of our geospatial engineers, all of our capability to build foundational maps, foundational geospatial estimates are all delivered by our PEO, and all capabilities that are critical in this industry and government partnership. And there's a lot of other capabilities in our PEO. I'm sure there'll be plenty of questions. I'm happy to answer them. Happy to answer them after the panel here. Thank you again for being here, and thank you for having me.
Major General John Rafferty is making his first appearance wearing 2 stars today. He promoted last Friday from 1 star to 2. No pressure, John.
Thank you. Right, we had a really good party in Oklahoma on Friday night at Fort Sill. That's where I'm based. So I'm almost 4 years as the director of the Long Range Precision Fires Cross-Functional Team and a plank holder in Army Futures Command. And Ed kind of led into it at the beginning when he talked about a holistic approach towards modernization. But as the Army wrestled with a pacing threat, an emerging operating concept, the Army senior leaders really had to go to some of our foundational principles as an Army, and one of those is unity of command. Who is responsible for modernization in the Army? One commander. And in that lens, that's how the emergence and the birth of Army Futures Command came. But at the top, there's unity of command. So the AFC commander has unity of command across a large organization. At the cross-functional team, the C is not for command, and it's not for checkbook or authority. What we have is our job is to be responsible for this and to lead across .MOPF to get to what Ed talked about, developing requirements and delivering prototypes. And so our foundation is to bring the team together based on that shared understanding and that unity of purpose. Steph talked about MDO, and the fundamental challenge of MDO is one of access. Layered enemy standoff that exists at echelon. The tactical echelon, it breaks us up as a combined arms team, prevents us from doing what we do best as an Army, which is combined arms maneuver. And that's the long-range artillery and sophisticated air defenses that are integrated at the division and down to battalion tactical group. At the strategic level, it denies the joint force access, separates us as a joint team, and denies us access, exactly what A2AD is designed to do. So our long-range precision fires effort emerged as the Army's #1 modernization priority because it enables everything else. At the strategic and operational level, it enables the joint force, and at the tactical level, it enables combined arms maneuver to close with and destroy the enemy. So on a day-to-day basis, what we work on is the big M's. So that's the new self-propelled howitzer that we're working on that takes currently fielded cannons, shoot 30 kilometers. We're already ranging 70 kilometers. We're going to deliver a battalion set of that starting next year. It's the precision strike missile, which is replacing the Army tactical missile system, which goes about 300 kilometers. The precision strike missile will go more than 500. We're working with the Rapid Capabilities Office on the requirements and .MOPF integration for mid-range and hypersonic capabilities. But But it's interesting to shoot farther with more lethality, but we've got to be able to see farther, sense farther, target faster, process missions faster, to deliver the kind of lethality at the scale and speed that our Army is going to need in future conflict. And so we have worked very closely under Willie's leadership as the Army's campaign of sensor-to-shooter campaign of learning. Now Mike is taking that over, but we're partnered every step of the way with him because we need to be able to see, sense, target, and process faster. The Titan system that Mark talked about, we've developed what we're calling an application, synchronized high up-tempo targeting, which is a FIRES app that will exist on the Titan ground station, driven by the commander's high payoff target list, driven by the target selection standards and the attack guidance matrix, will help automate at the speed and scale the calls for fire at the targets that we're going to find in this rich data that Mark was talking about. In that way, we think that geospatial intelligence plays a huge role in helping us actualize the Army's targeting methodology of decide, detect, deliver, and assess. And so great strides that are happening in this field here are going to be key to us fighting and winning in the future. And so I'm very pleased to play a role with my teammates here on the panel and happy for your questions.
Willie?
Well, I'll just kind of continue on a little bit and talk a little bit more about the campaign of learning. Many of you have already been a part of that, but we're at about our third year of that. And what do we mean by a sensor-to-shooter campaign of learning? What we mean is really one of the Army's biggest gaps today still is our ability to sense deep and see deep over that A2AD that General Rafferty mentioned, target that, and then as John mentioned, is getting after the execution and the killing of the target. But the challenge still remains our ability to see deep and then rapidly target and get that information back to our shooters. So the campaign of learning was developed about 3 years ago in order to focus our learning demands on that and help start prototyping things to be able to get after that problem. We do those both in Europe and in the Pacific with operational units. We do live fire operations on the ranges. With those, we collect the data, we do assessments, and then we get back with our PEOs and our other folks in the S&T community and then analyze where we're at and where we need to go in terms of prototypes and new sensing capabilities. So I thought I'd share a few things that we've learned. So first of all, of no surprise to you, our timelines, we need to get our timelines down. I mean, that's kind of a no-brainer. But how do you do that? Well, there's a material solution and there's non-material solutions. Let me talk material first. So one of the things is really a lot of the sensors today were built more I will say overhead sensors, built with more of a strategic mindset, not more of the rapid direct drop data directly down to theaters where we need it. And so we are prototyping systems that are able to rapidly take pictures, process that data, and drop it directly down in theaters to our commanders and our systems such as Titan that are in the field. That we found that's an absolutely essential capability that we need. But it requires a technical capability both on orbit and a new capability down on the ground to be able to process that data. The second one is really about getting standardized data formats we talked about open systems architectures. There's a lot of great capability being delivered, but we can't drag 15 antennas on different frequencies and have swivel chairs and people making different connections. We've got to get these down to the point where they're all coming into a central location in theater in the recognizable format, or at least in an open system architecture, so it can be immediately usable. That is valuable time that's wasted, quite frankly, when we have to do swivel chairs or manually move things across domains. Third, we get into less of the technical, more really of just the art of doing it. And really, we've got a lot of paradigms and processes that we've been using very successfully for many, many years in terms of how we use and collect and analyze and distribute geospatial information. But a lot of that's got to change when you bring a tactical formation into this equation. That data, we don't have time to have that data sit and be processed or travel halfway around the world to be processed. It's got to come directly from the sensor down into theater to commanders and to systems that can use that information, process it really quickly, and then again, get that into the fire solution so our soldiers can act on that. That's an entirely different architecture than we've been accustomed to using in the past. And so that's part of what we're doing in the Sensor to Shooter campaign, ironing out these new architectures, using a lot of these prototypes to find out where we're making success and where maybe we aren't, and then again, putting that all into a package and then starting to streamline and standardize our architectures for both in Europe and the Pacific. So that gives you a little taste of what we've been doing. You may have heard of Project Convergence. That's one other area. The EDGE series that the FVL team is running, Scarlet Dragon over at the 82nd, those are all venues. But there is an ongoing experimentation in Europe and the Pacific that the CFT, the AT&T Space CFT, along with our other brothers and sisters manage. We're doing those off and on all the time. So how can you get involved? Get involved in those. If you have systems you want to experiment with us, we're ready to work with you. But we can also partner you up with our folks who can help you with what the data formats need to be, frequencies that are common, those types of things. I'll leave it with, I'm really encouraged where automatic target recognition is going today. It's really emerging as one of the game-changing, and I know it's an overused term, but one of the game-changing types. I'm not sure it's where we need it completely yet, but many of you are working that, and I'm encouraged by where we're headed. But we really need to focus on the data formats and other stuff going forward. So again, I'm thrilled to be here today along with the rest of the panelists and a proud member of this team, and really look forward to your questions. Thanks.
Thanks very much, team, and thanks to the audience for your questions. Some great ones coming in. I'm going to start with picking up on the theme of the campaign of learning and use it slightly broader than the Sensor to Shooter campaign of learning. But it's a big part of modernizing the Army. We have to make sure that we are modernizing against the right foes in the right way to be successful in the future. And knowing exactly what that is requires the kind of intense study that we've mentioned up here from each of the panelists. So the first question for General Ahern is, as you have conducted the Future Studies program, what preliminary conclusions can you draw about how geospatial intelligence will be used in the future?
Thanks, sir. So just as what the Future Study program is, from a war game perspective, again, from a concept you have to experiment, and we're trying to have a concept that with technology that doesn't exist, which going into Project Convergence, it's really helpful to have technologies that you can pull out of a lab at least to put into the dirt. So we're trying to look into the forward for 2040. And some of the challenges that we see, that you can already see a lot of glimpses of, is that you can't hide. So we're calling it a transparent battlefield, or that term may change. And it's not that it's constant and not that it's stable, but if people, whether it's actual countries or people across the community, want to be able to see things, they can usually find you. And if they can find you, you're really at risk of survival. And so we still need to achieve surprise. We still need to be able to mass effects. Understanding what is actually on the ground is really helpful. A second thing that we're seeing is that kind of machine-on-machine warfare. And I'm not talking Terminators. We are probably not going to have Terminators in 2040. But sensors, small robotics, we're already seeing things in drones. The ability to have machines paired with humans having warfare is coming. You can't just have autonomous systems going out and figuring out what they're supposed to do. GEOINT has a huge application for that, and having the machines that they're learning, the people that are helping them learn, and where they're at on Earth. And the last thing I'd say, just from what we're learning, is that the sustainment methods that we see right now are only going to get more capable in the future. We don't think, again, by 2040 we're going to have Tesla tanks. But the ability to have electrified vehicles, the ability to have semi and autonomous resupply, the ability to have fewer humans putting large amounts of fuel onto the battlefield could have a huge difference. But again, if you're trying to do that, you can't just send them out and hope they figure out where they're going. And so the applications from a GEOINT perspective are absolutely critical to what we're looking at today.
So the next question, I think all of the panelists can contribute to, and it's basically, what are we learning from operations in Ukraine? There's a question about what are we learning about multi-domain operations in Ukraine? What implications for sensing and long-range precision fires are we seeing in Ukraine? And what are we seeing in the use of commercial imagery, which General Clark talked about, General Clark and Admiral Sharp both talked about this morning. I'll start by saying we're 61 days into a major ground combat operation in Europe. It gives us a really unique opportunity to see how ground combat could be fought in the future based upon what we're seeing today. But it's really early in my mind to say that we have learned anything that we are going to 100% export into future concepts or change the course of the trajectory of our technology investments. It's really interesting. We're learning a lot, but I don't think we've slapped the table on anything and say this is what we have ultimately learned. But Willie, why don't we start with you?
Well, I appreciate the comments made earlier about commercial imagery, and I'm your biggest fan, quite frankly, but I think there's a couple things we need. We need persistence, defined as the ability to be able to revisit an area in the world rapidly or constantly. But I think we can do that through a number of sensors. I think it's through not just space-based, it's through airborne, it's through high altitude, and it's sensor agnostic, but the ability to integrate and seamlessly integrate those sensors in a way that's meaningful, and I can't understate that. And then I think we're also learning that a lot of times, having that persistence, which is absolutely essential. I'm your biggest fan. We need everything we can get, but if you can't get that down to a tactical user in the field in a format that they can rapidly use, then you got a lot of persistence, but no real warfighting capability. So, right? So let's not lose one or the other. Let's connect those two. And then again, you need some authorities, right? You need the authorities to be able to task. You need the authorities to be able to rapidly process. You need some of those types of things. And we're charting some new ground. 2 new MOAs that were signed. Well, one not so new. We signed one, the Army Secretary signed one with NRO NGA a couple years ago, and that is to rapidly prototype both sensors and systems and architectures. And the chief just signed a MOA with the Space Force just recently to do much of the same. And so again, we're not doing this alone. We're doing it with all of you, both commercial across the industry, but also with our other services. And again, it takes that team to work off of common standards, joint standards, and be able to rapidly move that data across the battlefield.
Thanks, Willie. John?
So, sorry, I just made a couple notes. So, one, that leaps to mind is what we're seeing actually validates what you described earlier is a holistic approach to modernization, not a piece of kit, but across from doctrine to facilities, focus on training and leader development, in integration and creation of capability. Like that is it's a complete validation of the, at least in my opinion, of the Army Futures Command and largely the Army's approach to this. The second thing for me it validates is our approach to training and combined arms training. It's hard, it's expensive, it's difficult to do, but you can see why what the shortcomings are if you don't invest in that. And then the third thing is it validates what is the crown jewel of the United States Army. It's our non-commissioned officer corps, and they are the envy of the world, and you can see why it's on full display. To dovetail into Willie's point about the role of geospatial intelligence in this, I think one of the things that we're also looking at as I talk to some of my counterparts that are forward in the theater is taking advantage of the type of intelligence and data and information that we're getting and being able to share it with a coalition, because we're talking about a little bit about what we do, but we're not going to do it alone. We're going to do it in a coalition setting, and we're going to have to be able to share this information rapidly, because we are going to fight outnumbered. Whether or not they're good or bad is something that could be argued now, but the quantity is something we're going to have to deal with in the future. And then the last thing is, based on what we're seeing and the difficulties that our adversaries are encountering, it helps us put into context things that are more tradable in the near term. you can really see where they are. Are they really 10 feet tall? And sometimes we tend to maybe paint our adversaries 10 feet tall when maybe they aren't. But that doesn't mean we shouldn't shoot for that full capability, but can we get it out there faster and trade in the near term?
Mark, anything from your perspective?
I just have one very short thing to amplify General Rafferty. The situation is extremely dynamic. The intelligence demands are changing and evolving as we watch this conflict. And we have got to build our systems that can adapt in a dynamic way as the threat adapts, as our data demands adapt, as different sensors enter and exit the environment. And so Mr. Nelson talked about those data standards, ensuring we get the tactical user that information. And what underpins all of that is an infrastructure that allows us to do that in an open way and an adaptable way, that we're not waiting 3 months for the next delivery of software or a year for the next delivery of an antenna, that we deliver capability that can adapt in that dynamic environment. I think that's the very clear observation that I have from a material perspective. But thanks.
And so would absolutely agree with all that said. And so maybe just a little additional, a different tack is that I think it also reminds us that countries have very unique ways of approaching warfare, and that our future warfare must remain American to its core. But those who we are fighting against probably won't pursue the same approach. And so the ability to have information that we can share very quickly across communities, across countries, across allies is absolutely essential. We make mistakes, of course, but we hold our people accountable. Being able to help, as we're looking to future warfare, to understand what others are trying to do before they are doing it, just give people on our side more time to respond and react. And I think that's an additional thing that we're trying to make sure we're learning from this.
So just real quick, I'll take a sort of a strategic perspective of it. And if you look at the information that we're talking about and moving data around, what I've learned or what I've seen is the reemergence of the I in the dime of the national, thinking about our national power. But if you bring it back down to sort of the operational perspective, the Army's information warfare concept, that's sort of validating where we want to go and where we want to make investment in information warfare.
There's a couple of questions that are going to be very appropriate about sensor to shooter. And, every time we get together to talk project convergence, the gist of this next question is really at the center of it. How should we keep our finger on the pulse for data format standards and downlink requirements as they emerge? And the follow-on question to that is, what open standards are already being applied in the sensor to shooter kill chain, kill web?
Well, I'll start, and I'm gonna, at the risk of calling out people here, he's already laughing back there. So I have two folks here that are very involved in the community on data standards. I encourage you to come talk to me and Mr. Nelson about data standards. But Dave Cray here, put your hand up, please, and Matt Crow in the back, who's trying to run away. We engage with the community, we engage with industry, we engage with the intelligence community who define a lot of the standards that we implement. But we are absolutely open-minded about how we want to deliver that data. There's no parochialism, right? We want to protect your intelligence property as an industry partner, but we want to do it in a way that we can share that information, which has been a common theme here for all the panelists. And so if there is concerns or questions, please do not hesitate to talk to us. There is always a common sense approach on how we can deliver that data. But what's critical to us is ensuring that that data can get to a tactical user. And that's not just data formats, that's how we deliver the data, it's how it gets presented to the user, and it has to integrate, because geospatial intelligence is a critical enabler, but it is just one data source that our intelligence professionals and our sensor to shooter capability has got to deliver. And so I don't know if Mr. Nelson had anything else.
No, that's great. I want to follow on a real critical point to that, but the sensor to shooter campaign learning team, that is a joint team, has regular meetings that talk standards. It gives you a person and a phone call, and a friend you can call to understand those, and a community of interest that works through these standards. So get with us, and we'll absolutely get you connected with that, and then you can talk really the beeps and squeaks, which is what I'm sure you really want to know, and we can get down to that level. But I think here probably we don't need to. But there's one point that we've hinted around, but I'd be remiss if I didn't bring it up. So we've talked data standards, we've talked data fabric, we've talked how darn important it is to get to the warfighter, but we got to talk about the communication paths to get there. All right. Generally speaking, we live in a world where we can pull up a cell phone and download a file in a blip, right? We got gigabytes and fibers to our homes, and we generally forget that the real world we're fighting in has none of that, right? Or some of that, but it has some of that at different echelons. So when you're prototyping and thinking of your individual systems, think about how that data's got to come down. How is it going to get across a brittle network over thousands of miles and island hopping across the Pacific, right? There's no always-on 5G across the Pacific, right? There's not. And so, I mean, it's obvious, but I'm just saying, let's think about that. That's another challenging fact, and something that's coming out of the campaign of learning in terms of how much data can we really send across some of these pipes. So think about getting the data down into just what we need, right? So the images are real cool. They're great. The image clarity is wonderful, but really it's about the data behind the image. And that's a lot smaller. And that's more easy to get across the data fabric. And that's what his Titan needs. That's what General Rafferty needs into a FATIS to his guns. The pictures are wonderful. It's the data. And to quote the secretary, and I think it was a good quote, data is really the new ammunition of the future here. And so think about that. Data fabrics, getting it to the warfighter, but doing it across very, very brittle and very, very low bandwidth types of networks. That's a big challenge we can use all of your help with.
Anything else, John? So a couple questions about Titan, which I think is a very good focus for industry and for our partners who are here. And Mark, it's basically, can you discuss or maybe clarify the difference between the Titan space prototype and its relationship to the program of record?
Yeah, sure. So today we have two pathways of prototyping for the Titan program. We have a space prototype that will deliver this summer, and we'll do that to the MDTF. And then we have two contracts with two competitors building Titan prototypes. And so what's sort of the difference? Why did we go this route? We want to be able to show and prove that we can integrate into an architecture that is our ability to integrate for the future. So as new sensors come on board, as the Air Force invests in new capabilities, as new algorithms emerge, we want to be able to seamlessly integrate and prove out how we have an open infrastructure. So we decided to do the space downlink component as a separate component so we can prove out in the future what the underlying target architecture will be for Titan. It's also not the only opportunity industry is going to have for Titan. Our vision is to turn Titan into a platform to onboard and offboard capability in a very seamless way. And as I've mentioned to many of you as I've been here at the conference, we don't necessarily have the exact right way of how we're going to do that in a quote-unquote production, right? We don't know what production looks like for a capability that has to evolve over the next 5 to 10 years. And so we're going to rapidly do this prototyping phase and learn a lot about what the architecture should look like. And we want to hear from industry on how the future of the Titan program should look like. Today we see that as sort of a dual way, right? We've got to deliver hardware that has Titan in our echelons, and we see it critically as a software program as well, where we're onboarding and offboard these algorithms and capabilities in software. And so we're still evolving what the future of Titan program will look like, and these prototyping activities will help define that. And I don't know if General Rafferty or Mr. Nelson, you want to comment on how the campaign of learning is proving that out or not?
Well, it absolutely is proving it out. When I was told that I was coming to the world's largest in-person gathering of intelligence professionals, I said, well, I'm not coming by myself. And so Mike Benner, you can raise your hand over there. Mike's our intel officer on our cross-functional team. We've held him hostage at Fort Sill for the last over 3 years. And Mike and his team have been, really as much on Willie's team and as much on Mark's team, working the integration and the transition of the synchronized high up-tempo targeting application over to the Titan program as an example of something that we spotted 4 years ago as an S&T effort that wasn't exactly what we wanted, but it was enough that we could claim it, align it to our program, and then spend a couple years getting it where we wanted it to be. And it'll be ready this summer alongside the Titan prototypes to really prove out that capability. So I think to what the way Mark described this, how do we see the production of a capability that's going to have to evolve over the next 5 to 10 years? We don't know either. That's why we're on your team. That's why we're transitioning to you, so it'll be your problem.
Wait, I thought you were getting the hard questions. I thought that was our agreement. Yeah.
I'll throw one more. I'll throw one more thing on that just to complement the conversation, and that really is, part of what the campaign of learning is teaching us and will help inform the requirements for Titan is what information is needed at what echelon. There's a theory that you need everything everywhere. I don't know that that's accurate. I don't know that that's possible. And I also, how much information do different echelons at echelon need to be combat effective? And part of, again, the prototyping experimentation is starting to work that out. And then we'll be able to help inform the requirements that help then generate what Titan starts to look like in the future. So again, it's just the benefit of prototyping and what that allows you to do. Instead of spending years writing an unperfect requirement that's going to be dead wrong, you have a much better requirement that's in an iterative process that hits the ground, that's been soldier infused, and you're ready to go when your program of record hits its procurement. So, thanks.
Just real quick, sir. I think Titan gets described as the next generation ground station. It's way more than that. It is the future key analytic node for the Army, at least at the operational and tactical level. And I think I'd be remiss if I didn't highlight the success of the space component ground kit that we've integrated using TenCap and the partnership with the IC and getting capabilities that were developed by the IC down into the services.
It's great that you put that in there, Jimmy, because that was going to be the focus of the next question. But we've already covered that. Great question about human capital that I'm not going to try to answer. As we were putting the panel together, like I said, I tried to make it what General Rafferty said, everything from doctrine to facilities, and there's the human capital aspect is part of that. So I thought about having AFC's human capital officer as part of the panel, but we just ran out of chairs. But how we deal with human capital is absolutely part of the Army of the future. And clearly the way that we do talent management today is not the way we need to do it going forward. Steph, go ahead, Willie.
Well, two things jump out at me when you talk human capital in this conversation. It's really the need for data scientists, and really where the Army is going with data scientists and the development and putting these folks out into operational units. I think we're going to see some success. We're on the very beginnings of that, but that's one. And then really, and again, you all know this, but it's that algorithm development in the field. The ability to adapt both algorithms and models real time as a situation changes, and the ability to do that with talent that just we don't have on board today. And so again, the professional development, education, and grooming of those folks. And then I think we're going to see both data scientists and algorithm developers much more in the future and much farther and deeper in the field than you would have ever imagined before to make the systems that you all are working on remain relevant and capable in the future. So I just think those are two things that I think I'd throw at you.
And I would add to that public service announcement for the Army AI Integration Center at Carnegie Mellon and the Army Software Factory that's in Austin with us. There's another question about Ukraine, so pivot back to that for a second. And Steph, it's about logistics and everything that we are hearing through the media about the failings of the Russian logistics system. Steph, what are we learning about the joint contested logistics concept that's adjacent to what you're working on? Not necessarily vis-a-vis Ukraine.
Learning lots. I mean, I think one of the challenges is that you can't wish away physics, you can't wish away geography, and the challenges to be able to connect the data, to be able to connect the sensors of the shooter, the C2 node in near real time, and sustainers. This is the terrain matters. The multi-domain systems that we're pushing both the information but also the supplies that both sides are trying to use have real limitations. They have real vulnerabilities. I think the resiliency that General Clark was talking about this morning plays out in spades in the logistics, but I also think that this is not a challenge that we can look at and say they're really awful. And so I think we're really trying to make sure that as we're thinking through today, tomorrow, into 2040, if you can see it and it's a high value, you're likely to be targeted. And so these are some of the challenges that we're really trying to wrestle with. But at the end of the day, humans need food, they need water, they need munitions. And so just trying to make sure that we're not wishing away the problem because it looks really bad for some.
At an emerging mantra that's come is sensor to shooter to sustainer. And our partnership with the Army Sustainment Command and Army Materiel Command on our extended range cannon artillery system, which is an additive capability in a heavy division, it's going to need a lot of sustainment. And so we've been working with them from the beginning to right size the sustainment that's needed for that from all aspects of logistics and sustainment, to begin to automate some of the processes by which we keep track of ammunition, inventory it, and request it. And starting to think in this sensor to shooter to sustainer format is really helping us, I think, anticipate better so that we're not, to Steph's point, with large stockpiles of ammunition and ammunition supply points and things like that, waiting for the call, that we're anticipating based on the flow of the battle, and we can do a better job of minimizing our vulnerabilities and maintaining our operational availability in these challenging scenarios.
I think probably for Willie, John, and Mark, a question: how can new geoanalytics capabilities be leveraged for high priority missions, specifically high resolution 3D for precision targeting?
Well, I'll start, and it won't be too technical, but what we want to be able to do is to really, like I said at the beginning, actualize our targeting methodology of decide, detect, deliver, and assess, and be able to detect with enough assurance, enough confidence that we're not deciding again. The decision was made up front. The commander said, this is the high payoff target list. We must attack these targets in order to enable the scheme of maneuver to accomplish our operational objective. Then we assign our detection prioritization to get after those targets in the right order, in the right sequence of the scheme maneuver. And then we're supposed to deliver. We're not supposed to run up to show somebody a picture. The order has already been given. But some of that has to do with lack of confidence in what we see. So some of the more high resolution images that could be presented in the future will help us, like I said, actualize this D3A process and move more quickly.
Wow, that was good. I'm not sure I can top that. But yeah, multi-phenomenology, and as you mentioned, 3D is a great capability. But really, it's that synthesis also to get to John's point. Is how putting multiple sensors together to help beat down, or raise, in this case, the confidence level as quickly as possible. And again, in my mind, it's multiple phenomenologies kind of help you do that. Given some have day-night limitations, some have weather limitations, but some excel in those areas. So you're using the best attributes and combining the best attributes of the different sensors to rapidly get to a decision point. So I mean, I think that kind of gets to the gist of the question, I hope. Mark, I don't know if you had anything else.
I didn't have anything to add. Thank you.
What quick thing though, we're talking a lot about sensor to shooter in the targeting process. Before that, we have to have situational understanding so the commander and staff know the environment that they're operating in. Those phenomenologies contribute to that greatly.
We'll do one last question so we don't run over our time here. But I think it's a great way to end, and it will take us to project convergence and some of the things that precede project convergence. And Mike, if you need to storm the stage to be part of this, you're very welcome to. But it's about rapid prototyping, and it's about integration of sensors, platforms, AI engines, comms links, mobile edge compute services. What integration labs exist, and where do we go to engage for validation of fit to concepts and requirements? So we're talking JSIL, I think.
What a way to introduce yourself. Hi, Mike Monteleone, formerly DevCom C5ISR Center. You may have heard something called the Combined Joint Systems Integration Laboratory at Aberdeen Proving Ground. That's one major investment the Army's made in the last 12 months to bring together all of these different technologies across the different functional areas and explore a lot of what we talked about here. Really looking at that sensor at that finest level as it works its way through an architecture, as it works its way through those difficult magic devices called cross-domain solutions, and eventually get to either a situational awareness or understanding application, or to a targeting system or a gun itself. So I encourage all of you, I'm going to be sticking around here if anybody wants to talk anything about the JSIL. And the one big thing about the JSIL, it's not an individual location. The Army also invested in the infrastructure to federate its laboratories across all the different functional areas to bring that expertise and those capabilities into one fully federated environment. So appreciate that.
Anything else on JSIL? So we've got a short reprieve here. We'll do one more question, and I think all of the panelists might be able to contribute to it. Project Convergence is undoubtedly the Army's biggest experiment that we run every year. And we'll do it again this year. We've done Project Convergence 20, 21, and this year we'll do 22. It is the capstone of all of our experimentation. It's a very, very big deal for the Army, and increasingly for our joint and combined partners as well. So I'd like each of the panelists to just give a brief view of how you see PC22 and your contribution to it this fall.
I'll start. So Ed nailed it. All roads in Army Futures Command lead to Project Convergence, or else. It is everything we're working on needs to be integrated into this experiment, so we can begin to illuminate what's possible and inform our own requirements. And I think most importantly, to the human capital question earlier is how do you take a people first approach to modernization? Everything's about the soldier who's going to fight with it. And that's exactly what Project Convergence gives us the opportunity to do. Put it in the hands of soldiers in a relevant and challenging environment under tough and demanding conditions, and let's see what they can do. And I think that has been probably the most valuable part of it. It's not just the months leading up to it of connecting everything and building the architecture and the rest of that, and making sure that we can do it. But it's when we hand it off to our talent out there, to our talented soldiers and commanders in this in taking what's most important in AFC's approach to modernization, which is soldier-centered design. And so as you are looking at the opportunities to get involved in Project Convergence or Sensor to Shooter Campaign of Learning or any of the other experimentation efforts that are out there, you got to be thinking about you're going to put it in the hands of a soldier and get feedback.
I think you and I have been on all three of them, or two of them, third one coming up. I think it's been exciting to watch Project Convergence grow and really mature into what General Rafferty just mentioned, and really that's that involvement. It started really with a pure S&T effort, basic fundamental architectures. It's now grown to more conceptual, and now we're bringing in the allies, and so that just continues to up the game and continues to push our architectures and our systems. I think another key takeaway is the ability to get scientists and engineers from the laboratories into the field, in the dirt, side by side with the soldiers, using the equipment. And what comes from that is absolutely amazing to watch. They're able to collaborate, they're able to fix things real time, change things real time, and then from the end of that, codify that. And what you're going to see a real push now, so we've got our engineers out there, we've got our soldiers out there, we've got concepts now really forming up. I think now it's getting that full .NLPF, getting our requirements writers out there, getting our CNIDs and ACAMs out there to start capturing what's working, informing requirements, updating requirements where needed, so that can get into the internal process within the Army to institutionalize what we're learning. And so again, that's really, it's been wonderful to be part of Project Convergence so far and really watch it mature to where it's at right now. So.
Yeah, and the only thing I would add is I think Project Convergence personifies this partnership between the CFT and the PEOs, so that we use it as an opportunity to get that feedback for not just the requirements, but the gaps we have in our capabilities and the capabilities we want to prototype. So it's a fantastic opportunity, and we look forward to shaping the next Project Convergence beyond just 22. That's all I got.
And so in addition to doing Army concepts, we're the Army lead for the plug into the joint warfighting concept. And as the JWC has evolved and matured, this is an Army-hosted experiment, but it's also providing the opportunity for each of the services to come together of how would we actually use our capabilities to operate in a different way. So we have to do our own homework, but if we're doing our homework alone, we're not going to be able to fight like that. And so whether it's the joint partners, allies, and partners is absolutely essential from a concept perspective as well.
So I think we're getting the hook. So all I would say is our responsibility is to fund it.
Somewhat important. I'd like to wrap up by saying thank you. Thanks to you for being here and for your attention and for your questions. And thank you to the panelists from across the Army who took time out to interact with the GEOINT professionals, the best GEOINT professionals in the world. So to my teammates from ASALT and Army Futures Command and Headquarters Department of the Army, thanks very much. And we'll be around. We look forward to talking to you. Thank you.